Alright guys, we're going to go on to this part, which is logarithms. We're going to solve the following exponential equations. And here's what you guys please remember about exponents is what we're trying to do with logarithms is work backwards and forwards between logarithms and exponents. So if you have a number to an exponent equals your answer, right? That's the same as your log to the base of that number. Your answer is here, and that's going to equal your exponent. Okay, I don't know if that helps or doesn't, but let's see. So we talked about how when you are to solve these, you're going to, I don't know what 2x would be, except I can do a few different things. Here is what you want to make sure you do. You want to find the same base, if you can. Okay, that would be ideal. You also want to isolate. So we're going to do some of this. Now, 64 and 4, I can put 64 in exponential terms. I know that 4 times 4 times 4 equals 64. So that is 4 to the third power equals 64. So if I rewrite this quantity as 4 to the third power, and I know that 4 to the 2x power is 64, which is the same as 4 to the third power. Now I can say, okay, these two numbers have to be the same because they're equal to each other. And with the same base, I need those to be equal to each other. So I can say 2x equals 3. So x would have to equal 3 divided by 2. And as we kind of talked about before, let's check that answer. So 2 times 3 over 2, does that actually equal 64? Well, when you multiply 2 times 3 over 2, you're going to get 4. The 2's will cancel out to the third power. And that does, in fact, equal 64. So I've checked my answer. Okay? So that is where we find the same base. That's a problem with the same base. All right? Now let's look at this. So here, what you need to do is isolate. This is one of those isolation problems because your exponent, your number with your exponent, is not on one side of the equal sign by itself. So you need to move everything over. So I'm going to add 11 to both sides. And I'm going to get 8 to the x power equals 16. All right. Now, that being said, I don't know what that would be. I'm trying to think of different ways to do that. So if I write that in a logarithmic situation, I can say, okay, the log of 8 is x. Okay. And so I'm going to look at that and say, all right, I really don't know what that is either. So I can use my change of base formula. A lot of times there's lots of different ways, so you can figure out which tools you like to use the best. That is the log of 16. Make sure you kind of remember that that goes on the top and that goes on the bottom. The log of 16 divided by the log of 8. So I can pop that in my calculator and say, all right, log 16, close my parentheses, divided by log of 8, close my parentheses. I'm going to get 1.33 repeating. I want to check my answer and just see. 8 to 1.333. Now I'm not going to get it perfect because of the fact that I'm estimating here. That's not a true number, so it may be a little bit off. Minus 11, what does this equal? 4.998, which is pretty close to 5. So there you go. Okay, since I rounded, it's not going to give me the exact number. All right, I guess if I put 8 to the 1 divided by 3 power, let's try that, minus 11, what does that equal? Well, that's awful. Oh, I know what I did. 8 to the 1, oh, I guess let's say 4/3. 4/3 power, because that's 1 1/3 minus 11. There you go. Okay, that's where it's not rounded. That's why we don't want you guys rounding. Okay, so here we have the same base again. Same base, 18. So the exponentials have to be equal to each other. So you just say 5x plus 2 equals 20 minus x, and I'll let you figure that out. This one, same type of thing. 3 to the x equals 15. Well, I don't know what that is. I don't know that that's going to be a whole number. So again, I'm going to use my change of base formula. But in order to do that, you have to write it into log form. Write it in log form first. This is log form 2. I don't know if I talked about that enough. So with your log form, you start with your base, log of 3. Your answer goes there, and that's going to equal your exponent. Make sure you know how to do this. So that's going to be log of 15 divided by log of 3 equals, and then I just plug that in my calculator, log of 15 divided by log of 3. All right. I didn't get to see that. But there you go. All right. 2.46. All right. These, now, so these are basically exponential equations using the same base or using your log form. Now we have exponential equations, and all you're supposed to do is put it into logarithm form. So you're going to use your base, log, base 2. Your answer equals x. Okay, that's all it's asking. Okay, I'm not going to do all of them. Then we're moving on. Now rewrite these in exponential form. So hopefully you can do this in exponential form. I'm not going to do that for all of these, but I'm going to show you, right? You've got your log, your base, your answer, and your exponent. That's your log form. Your exponential form is your base, your exponent, your answer. So do you see? Boom, 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 boom. All right, let's see. So here you've got your base of 2 to the 16th power is going to equal x. So all it's asking you to do is just rewrite it in log form. That's it. If you want to solve it, you can, but all it's asking you is to rewrite it. These are asking you to evaluate, so you have to write it equals x. 2 to the x equals 1. Any number that equals 1, x is going to equal 0. That is one of your log properties. Any number to the 0 power is going to equal 1. Okay. So hopefully you can do all these, change them into exponential form, and figure out what they are. That you actually have to evaluate. All right. And let's go on. So these are expressed as a single logarithm. So this is using your log properties. All right. If you guys remember, when you have log of 2 plus log of 3, then you actually get log 2 times 3. That's one of your properties, but these all have to have the same base. Then you have log of 2 minus log of 3. That's going to be log of 2 divided by 3, right? These are your log properties. Then if you have log of 2 to the third power, that's the same as 3 log 2. All right. So hopefully you can do those. We'll go over some of these in class, but if you, well, this would be log 15, 5 times 3, right? Log 15 to the 15. So 15 to the x power equals 15. What do you think x is going to equal? X is going to equal 1. Now, this is fine because it just says express it as a single logarithm. That's actually the answer. But if you wanted to go ahead and solve it because you know the answer, that's it. All right. Same here. You're going to multiply. This is going to be your log base 3, 4 times 6. So your answer is going to be log base 3 of 24. All right. So this may be the harder one. You basically are going to take this. Actually, the opposite. Move it over here. So that's going to be log base 9 x squared. Squared, that moves up, plus log base 9x. Now you multiply those two together and you get log base 9x. 2 times 2 is 4. Plus log base 9x. Now since I'm adding these according to my properties, I'm going to multiply them. So I'm going to get log base 9 x to the 4th times x, which is log base 9 x to the 5th power. Which then, you could also put 5 log 9x. Okay. All right. These solving of logs, let me just tell you, you've got to kind of be clever with these. If it's in log form, you're probably going to want to put it into exponential form. If it's in exponential form, so log form, you're probably going to need to put it in exponential form. Exponential form, you're going to probably need to put it in log form to solve. You just have to learn how to work back and forth from them. So if I have this, 3 to the 2nd power, if I put that in exponential form, 3 to the 2nd power equals x minus 5. Can I solve that? Sure. 9 equals x, minus 5. Add 5 to both sides. X equals 14, or 14 over here. Sorry. That equals 0. Okay. So you've got your x equals 14 here. So now here you're going to want to condense those because they have the same base. You're going to get 45x divided by 3 your log equals 1. Okay. How do you figure that out? Well, you can reduce that to log 15x equals 1. We know that our base is 10 because there's no number there. So if we put it in exponential form, it's going to be 10 to 1 equals 15x. 10 to the 1 power is 10 equals 15x, and then divide by 15 to solve for x. Get clever, you guys. Use your math skills to figure this stuff out. Okay? Now, since you have log to the base, log to the same base, you can take the logarithms away because whatever's inside the parentheses needs to be equal to each other. So you can just basically set these equal to each other and solve for x there. This you're going to want to put in exponential form and then solve for x. So that would be 6 to the 3rd power equals 2x plus 3. Got 6 to the 3rd power equals 2 minus 3. All right, hopefully that helps.